Good day. I would like to introduce you all my prototype for today entitled Transpunch, which stands for Transparent Hole Punch. So I would like to introduce you all my prototype for today. So the problem statement here is in the current hole punches are big and also over designed with the material. So my design here will save material and also the production cost. And my goal here is to use as little production equipment as possible to meet my cost goals. So other than that, people always lost their consistency when they are punching. So the more they punch, I mean like out of their consistency, they will have to waste the paper and then the paper will be full of wrong holes. So with this hole punch, you will have a proper consistency and also it'll be transparent on the handle and yeah, it's also a easy handling. Not only that, people also tend to misplace things when there is big and it's not handy. So this hole punch is made lightweight and also handy for the mobility. So the main objective here is to provide a hole punch that saves the users effort when they are guessing the hole and also to design the cheapest hole punch which is they can compete with the current hole punches and also the thing matters here is the cheap price and also a workable hole punch and other than that to help the elderly ones and also the aid the disabled one and SME industry with their office work and also finally the school students with their school works. Next, Transpunch consists of several items which are puncher die, upper punching arm, lower punching arm, compression spring, Allen screw, nut, and not forgetting the handle base. The handle is upper and the topper part. So if you see, this is our original prototype, and the design is rectangle, obviously, and then it has precise punching due to this hole here. So you can it ensures the precise hole alignment, and also there's a rubber base here prevents the device from slipping. It has a strong handle, durable metal construction to ensure a long-lasting service life, and also high capacity with diameter of 5 mm and also it is empty. Little paper can be cleared easily with this chart collector. So next, it's our functional diagram which shows the mechanical part and also the mechanism. So this mechanism is a common mechanism where general one which it uses for all the hole punch where we put the paper in and then we take out and then we punch it. Yeah. So mechanical part is divided into two which is mechanical arm, sorry, puncher arm and also puncher die. So next we'll move to the survey, which is I'm going to see on this, which is consists of 67 to 68 responses, where the design you prefer the most. So 33 of them said, I'm sorry, 55 of them said it's this design tree, so they are choosing this. And also with this picture, it shows that do you think this transparent will avoid long placement on a hole or not? So 22 of them said yes, and 21 of them said maybe. With this, you can see. I'm sorry if it's blur a bit. Yeah, 21 of them said maybe. So with this picture, finally, the features that they expect. So if you see this, they're expecting about the alignment and all. This they're expecting the material, and then the final one they're expecting the capacity of the hole punch and also the diameter of them. So following, it's the house of quality, HOQ. So there are three main points if you see down here the bottom part, which is price, material, and also the weight. So if you see, I'm gonna explain on this table, on these two tables which are showing the selection matrix and also the concept scoring. So here it is clearly seen that design 3 has the highest score of 36 in the selection matrix and also design 3 in this concept scoring with 28.5 with the highest. So it is really obvious that design 3 is the final output here. So the final specification that I came out is consists of 7 of them, which is the top handle case, bottom handle case, puncher die, compression spring, Allen screw and nut, upper punching arm, and also the lower punching arm. So the 7 consists of plastic, stainless steel, and also the steel. So the mechanism here, it shows the general mechanism where we fold the paper, we adjust the hole punch so that it will be center, we put the piece of paper into it, and then we align the paper again to be central, and then we carefully press the upper punching one to make it the to make the hole there. So these are the final design we came out. I mean, I came out of this. So by having this hole here, this shows the main objective we want. So if you can see the mechanism is normal, you just use this, you just push this here and the paper will punch. So this thing will move down here. So we insert the paper into here and then you have gap until here. And then here is the punching thing occur where the puncher die moves down. Yeah. So it's very clear here that the puncher die will be into the spring where it will be like this. If you can see the isometric exploded and here will be the two Allen key you can see here, Allen screw. So you can see it here. And then this two is this made of stainless steel, that's why it's in gray in color. So next we'll move to the cost analysis, which is consists of the material cost, where material cost is the total product cost. So if you can see here is the 37.86 is our total product cost. So these are the material needed, A to Z, all we needed. All it is needed. So this is the overhead cost, this is the machining cost. And then next we'll move to the return of investment, which is ROI. So what is ROI here? ROI is basically we have to add this 3.52, which is our production cost here, and also this material cost here. We will get our cost of producing one unit, which is 41 ringgit and 40 cent. And then the margin of profit is 50% here. So I just wanted half of the profit. So increase the selling price for one unit around 62 ringgit and 10 cent. There's a difference because this is the original. You see, this is the original. So this much we get the profit. 20 ringgit and 70 cent is our profit here. So the ROI is calculated using this formula. You can see gain and also cost. So the answer here is the ROI here is 37.93%. So I would like to move to the material analysis, which is also I would like to connect it with the sustainability here. So first we'll move to stainless steel. So it is starting from here, the process from continuous casting, hot rolling, cold rolling, and then you'll move to here. Years of the stainless steel can be used, and then it also can last for 1,000 of years. And yeah, it'll go on with the recycling method here, and then it'll go again from the number one, number two, number three, and then all. Okay, so the stainless steel benefit here, it is divided into five. There is five. So this is basically a sustainable one with cost saving, with the cost, with the material, with the production site, with the recycling one. So it's basically 100% recyclable because it can last up to 1,000 of years. So next we'll move to the PLA. So what is PLA here? PLA is basically a polylactide plastic. I'm sure most of y'all wouldn't have heard about this. So I choose this because the life cycle here really made me to be mesmerized because it's made of just starch. So we'll start with photosynthesis where water and carbon dioxide is needed, followed by disposal of food, followed by hydrolysis with just starch as I mentioned. It's just starch and I can't believe it till today. So it's followed by fermentation, lactic acid, which it is synthesized into PLA and then it's processed into products and then it's degradation and finally it moves just like that to the present to the photosynthesis and till again and again. So the recycling cycle of here is start with the plant and then also divided into two when it's the corn thing. So first generation law and second generation. So first is sugar and starch. Second is ignogenistic fibers. Third is PLA pellets. Fourth is PLA application, and then they recycle it. That is what made me so curious to know about it more. And then followed by the energy recovery again, and then it follows again from number one till number six. So finally, I would like to give some enhancement which in future most of them should take note of this where some recommendations are needed, for instance punching a paper with a hole reinforcement. So a hole reinforcement here is after punching a material, it is also a protection for the material so that you don't tear off or give away or something like that. So next is punch cum stapler. So as you all know that puncher and also a stapler has the same function because they punch and they is the same. So puncher it produces hole, but stapler produces the stapler pin. So this is a multifunctional tool where it uses the same mechanical action. So the design of transpunch mechanism, it's stainless steel and also it is made, as I said in the beginning, it's used to make the punching up. So this ensures the rigidity of the hole punch because even though you're using plastic, we need a thing that is strong. Yeah. So finally, by completing our transpunch research, maybe so in general, this Transpunch can compete in the market as this design offers a more faster and efficient solution on paper punching without guessing anymore. And also hence it can be concluded that this design is more reliable, efficient and also will help most of them with this solution. And in a nutshell, this design has completely fulfilled the objectives of Transpunch. So that's all for today. I would like to say thank you. Bye.